Okay, we're live.
Hello, everyone. Welcome to the Research Showcase in October 2021. My name is Martin Gerlach. I'm a research scientist in the Wikimedia Foundation. I'm opening this showcase. I'm very excited to announce this and introduce this. This will be an update from the Wikimedia Research Team about recent and ongoing activities on addressing knowledge gaps. We will have 4 short talks presenting different projects, and after that, we have hopefully enough time, around 20 minutes, for an extended discussion with Q&A. So if you have speakers, if you have questions for the speakers or around the projects that come up, please put them in the chat or on IRC. Emily, my colleague, will be monitoring them and relay them to us here in the room. Before I kick us off here, I want to mention 2 announcements. One is that we have been organizing a scientific competition for missing images in Wikipedia. It is hosted on Kaggle, and we invite you to participate. The deadline is on December 9. The second announcement is that next week we expect to launch the first ever research funds with the Community Resources Team. And those of you who are interested to apply for funding for their Wikimedia related research should keep an eye on the Wiki Research Twitter channel or on the Wiki Research L public mailing list. And with this, I think we are ready to go, and I'll pass it on to Leila. And I think we can start to share the slides as well.
Great. Thank you, Martin, and thank you, Miriam, for sharing the slides. Hi, everyone. My name is Leila Zia. I'm the head of research at the Wikimedia Foundation. I have the privilege of setting the stage for this particular presentation. Martin already shared with you some information about the next hour. So you're going to hear about a few different projects in the research team which have focused on building automatic approaches to bridge knowledge gaps on the Wikimedia projects. And you will also hear about the thinking of our team when it comes to the topic of equity and recommendation systems, and the fact that equity and recommendation considerations and models need to go hand in hand for us to at least assure that we don't further the inequities that may exist on the Wikimedia projects or reflected as a result of the inequities that we see in our societies. One particular point that I wanted to share with those of you who have been following Wikimedia research, Wikimedia Foundation, or Wikimedia community and projects over the past years is that this presentation is kind of a moment of celebration for us as a community, for us as a team, for us as an organization. You will see a few different projects in the space of recommendation systems and the topic of equity. And what I want to particularly highlight to you is that as a result of the investments within Wikimedia Foundation over the past few years, both within the research team and on the research team, and also investing more on the product front within the Wikimedia Foundation, as well as the machine learning platform team within technology, we have come to a place that building recommendation systems and bringing them to products or scaling them to many languages or different projects has become something that we can say it's repeatable. Of course, there are many things that need to be improved. There are ways that we can make these processes more efficient for doing research and passing it on to product and further development. But to me, kind of the part of the presentation today is the celebration of this moment that we have been able as an organization, as a community, as a movement to get to a point that we can, in a repeatable way, build recommendation systems and have considerations to make sure that these recommendation systems are equitable, or at least we think and we try to understand what are the inequities that they may introduce. And this is something for all of us to celebrate. And I'll leave you with this context. I pass it on to Miriam, who is going to kick us off with the presentation. Thank you, Miriam. Please take it from here, and please engage with all the speakers during the Q&A. Thank you.
Thank you very much, Leila. Hello, everyone. My name is Miriam. I am one of the scientists in the research team, and I'm very happy to introduce this collective talk about automatic approaches to bridge knowledge gaps in Wikimedia projects. Before I start introducing the topic of the talk, let me just introduce the research team and our collaborators. So the research team at the Wikimedia Foundation has 8 members between scientists, engineers, and managers, and Emily, who's our senior research community officer. The scale of the research problems in Wikimedia projects is huge. So we are able to operate at this scale only thanks to many fantastic formal collaborators from academic institutions from all around the world that work with us on solving challenging research problems to serve the Wikimedia communities. And so today, Leila has just introduced, Martin, Isaac, Diego, and myself are going to introduce you to our work around knowledge gaps. But this is really a set of projects that got input from everyone in the research team. Everyone has put energy and love. So it's really a collective presentation. So to introduce you the problem of knowledge gaps, I'm going to start with a principle that most of us know very well as one of the 2 principles of the Wikimedia Movement strategy. Knowledge equity is that idea that is encouraging us to include into Wikimedia projects that those knowledge and communities that have been left out by structures of power and privilege, and also pushing us as researchers to design technologies that can break down the social, political, and technical barriers preventing people from accessing and contributing to free knowledge. So one of the contributions of the research teams towards knowledge equity is to work on research, fundamental research and tools that can help addressing knowledge gaps. Where knowledge gaps are all those components and biases and inequalities that prevent us from reaching knowledge equity. One of the most famous knowledge gaps not for good reasons is the gender gap. But there are many more of such gaps that we are looking at and analyze and trying to bridge as part of the Addressing Knowledge Gaps research program. This program is a multi-year program and is really the product of the effort of many, many people in the research team and across many teams, as Leila was mentioning, at the foundation and beyond the foundation in the academic world. There are 3 main strategic directions within this program. The first one is about identifying the gaps. So even define what are the inequalities that we are trying to bridge. And to this end, we developed in September 2020 a taxonomy of knowledge gaps that collect the definition of all possible knowledge gaps in Wikimedia projects across 3 main pillars of our projects: content, readers, and contributors. The second strategic directions for addressing knowledge gaps is to measure this gap. Once we have identified these gaps, the next step is to use the research and the technologies that we know to automatically quantify such gaps. So for example, we can say that there are 80% of biographies that are about men on Wikipedia. And the metrics like this, we can develop for all gaps. And we are actually in the process of developing these kind of metrics at scale for many of the content gaps. And the third part is about bridging knowledge gaps. And this is what we're going to see today. Once we know what we're talking about in terms of knowledge gaps, we know the extent of those gaps. And so we're measuring knowledge gaps. The next step is to produce research and tools that can help us and the community reduce the space of these knowledge gaps. And so what we're going to see today is a set of research and tools that we have developed towards this goal. The overarching architecture of the tools and the research that you're going to see today is summarized in this slide. What we're going to see today is a set of tools and algorithms that we have developed to bridge content gaps through content discovery and recommendations. So everything starts with understanding knowledge gaps in Wikimedia projects. Part of the research is consulting with the community and the product team to understand what are the knowledge gaps in Wikimedia projects and what are the knowledge gaps for which we can provide tools to help bridge them. Once we have identified a gap that is potentially solvable through research and that is interesting for us and the community to solve, then we develop these algorithms that leverage large amount of data from Wikimedia projects and beyond, find connections between this data and discover pieces of content that can be added to Wikimedia projects to bridge knowledge gaps. And so by developing these algorithms that for automated content discovery, we can create list of pieces of content that can be added to Wikimedia projects. Obviously, at this stage, we're not going to automatically add this content to Wikimedia projects. The output of our algorithm is being incorporated into tools that are built for the community, and especially in our case for newcomers to bridge the knowledge gaps by incorporating the suggestions from our algorithms. And for this, we work with product teams that build these tools around the algorithms that we develop. And so what we're going to see today is three of these algorithms, three main algorithms that we have developed in the research team. The first one is a section alignment algorithm that Diego has built in collaboration with the language team. The second one is a link recommendation algorithm that Martin has built in collaboration with the growth team. And then I will talk about image recommendation to bridge the visual knowledge gap. It's a project in collaboration with the growth and structured data team. And finally, Isaac is going to talk about how we are working as a team and as a foundation to make sure that this recommender system that we're building are actually fair and equitable. And so without further ado, I am going to pass it on to Diego, who is going to talk about section alignment.
Thank you, Miriam. Thank you, Martin, Leila, for the presentations and for the nice introduction. My name is Diego Saez-Trumper. I'm a senior research scientist in the research team. I do most of my work together with Pablo Aragón in the other program that we have in the team, that is the knowledge integrity, where we try to keep the content or to help to improve the quality and integrity of the content in Wikipedia. But I also have been very lucky to work in this knowledge gap space for some time. And today I'm going to explain what we are doing with the section alignment work and how we are doing and in which stages of this work we are. Next slide, please. So what is the problem here? The problem that we have is that for many use cases, we want to understand how we can align content across different languages. Especially in this case, we're talking about how we can compare sections across different languages. And this can be used, for example, for translation. So one article can exist in two languages, but we don't know which content is missing in one of those languages. And the problem is that translation engines, like automatic translation services that we can use, they cannot be directly used in Wikipedia. So in one side, we have the language team that does an amazing work in what we call the content translation tool, trying to deal with all the problems around Wikitext, that is the markup language that people use to write on Wikipedia. So how we translate that the links are going to the right place, that the templates used in Wikipedia are translated in the correct way. But we want to go one step further with this, and we want to also understand how we can align this content, and especially in this specific project, how we can know that, for example, biography in English and biography in Spanish refers to the same content, the same, and this we want to do across languages. So next slide, please. So basically, our approach here is what we call cross-lingual section alignment. And what we have been working, and this is a work that we started several years ago, is instead of working on just translation, we want to do this that we call content alignment. That can be described as machine learning problem in very different ways. But what you see here in the picture is basically in two close sets, we want to create, to infer the links between this node that will be the section title in one language and the section title in another language, to understand when we have a mapping between these pairs of sections in two different languages. So we have been working on this, and see if we can go to the next slide, please. The first thing that we need to do to show that this is important and that there's a way, a path to be traveled here, is to see if we are able to do better than automatic machine learning translation. So when we started this, even we had less options in terms of the search translation engines that we were using, the ones that we have agreements to use from Wikipedia. Nowadays, we have more. We are, for example, in partner with Google Translate to do translation. But the first thing that we want to see is using, developing our own algorithm. We were in the same or better than these automatic translation engines. And we have already presented this a few years ago, and you can find a lot of documentation on this. But basically, the two technologies that we use here, or the two main ideas that we use here, was to use cross-lingual word embeddings. Specifically, we're working with fast text, that is a popular word embedding algorithm, and some Wikipedia-specific features. So the good thing about this is that cross-lingual word embeddings allow us to measure distance between two different concepts in different languages. And then this allows us not only to have the exact translation, that is what, like the literal translation, that is what a machine translation algorithm will do, but also to have related concepts. So we can really measure the distance between these two different words in different languages, and this is exactly what we applied. And you can see here in this plot, we annotated data with the help of the community in 6 different language pairs. And this was not that easy because, as you see, to not use just one language as a pivot language, that is what in some places people will do. We want to create these translations from all these language pairs. So from Arabic to Russian, from French to Japanese, from Spanish to English. And we will, with the help of the community, we were able to create this annotated data. So after annotating this data and applying our approach of cross-lingual word embeddings and Wikipedia-specific features, we had some ground truth, and we can measure how good we are doing. And you can see in this plot the improvement on top of Google Translate. That is the baseline that we use. And you can see in most of the language pairs, we do better than Google Translate. Just in two language pairs that are Japanese and French, and Russian and Japanese, Google Translate was doing better than our algorithm. But if we can go to the next slide, we don't need to compete with Google Translate. We can collaborate with and use Google Translate and other translation tools that we have, like Yandex or other systems, and use this as a feature. So if you use automatic translations as one feature for our alignment, we do better than all the than the automatic translation system alone. So this work was done already some years ago, as commented. If you want to learn more about this and more about the algorithm, you can check the presentation in the showcase in 2018, or you can also go to the Meta in Wikimedia Wiki Meta and check more details about the algorithm that we use there. And we also have created this demo tool with the SecRec at wmflab.org, where you can experiment how is this working in these 6 languages. And by the way, you can also help us to annotate more data to keep improving our annotations. But what we're doing now, that is in the next slide, it's trying to scale up these to more languages. So this prototype was developed for 6 languages, and now the language team wants to deploy this for production. So what we have until now is just this prototype. And the idea will be scale up at least to 100 languages. Also, given that this work was done a few years ago, we were using fast text and these cross-lingual word embeddings. That was the state-of-the-art solution at that time. Nowadays, there's more complex language models, more complete language models that works also in several languages. So another thing that we are doing is testing these new embeddings and new language models to see if we can improve more than just using the fast text alignments. And also we want to improve the recommender system that can, for example, help you to understand which is the most important section or the section with more information to be translated from one language to other. So this is what we are doing now, and we hope that during the first half of the next year, we will have this API deployed and hopefully used by the hundreds of thousands of users that are using the content translation tool from the Wikimedia Foundation. So that's me, and I think now we are passing to Martin.
Thank you, Diego. I will talk about the next section. I'm Martin Gerlach. I'm a research scientist in the research team. And this work on link recommendation was done with a team effort with the growth team and Jalal Jifala at NYU Abu Dhabi. Next slide, please. What we did here started from the problem that the notion that editing can and probably is hard. And this can be, there are many barriers to editing, which can make it very difficult to edit. These are not only technical, but includes those, but also conceptually and culturally, where to start, what to do, and so on. These barriers filter out many people who could be great Wikimedians. And this, they constitute a barrier to diversify our editor population. Next slide. Yes. One solution, one possible solution, the growth team actually came up with is a framework around structured task editing. And the idea is to break down editing into simpler tasks so that they are easier to understand, easier to do on mobile devices, and easier to get positive experience. The link recommendation was identified as an ideal candidate to test this as a prototype because it's well defined. It's a frequent and very attractive task type, and it's a low risk for vandalism. And what we were tasked with is to build a model that can automatically generate these types of recommendations in a machine-in-the-loop approach. That is, we're not adding those links with a machine or with a bot, but we propose those to editors, and they're the ones who do the final step of verifying and adding those potential links. Next slide. The link recommendation task, it is a common task, essentially can be considered as corresponds to an entity linking task. And after parsing the text, we actually have to solve 3 different portions. So we have to identify pieces of text that are not identify mentions, so pieces of unlinked text. We have to then generate a set of candidate links. And then we have to disambiguate those links and choose whether we actually want to link, and if yes, which one. Next slide. This is a well-studied problem in machine learning. However, in the context of Wikipedia, we're actually faced with a unique set of challenges. And first and foremost is the language support. So we have to, there's more than 300 different language versions. We would ideally like to support all of them. And especially it is important because the biggest impact is potentially coming for the smaller and smaller communities. Other considerations we have to take into account that there are different manual of styles that pose different constraints about what should be linked and how. And that we have to take into account considerations around transparency, scalability of these models. Can they be explained, these recommendations, and to also find a good balance between precision over recall. So making sure that those recommendations that we make, they are probably good recommendations. And I want to quickly go through how we solve these 3 different steps that I mentioned in the context of Wikipedia. Step 1 was the mention detection. So how we start is actually build an anchor dictionary. And that is that we look at all existing link in a Wikipedia version and just record what is the mentioned text and the link that it links to. In English Wikipedia, this is 7 million anchors and more than 107 million links. And then we, based on this, all these mentions, we just parse over all the text in a Wikipedia article, and with a simple string matching techniques, we try to identify if there are n-grams that match our anchor dictionary, which we could potentially link. Next slide. In the next step, we want to generate links. And once we have identified and mentioned the text, we simply take all candidates from our anchor dictionary. We remove certain types of links, for example, to disambiguation pages, and we also apply a bunch of other heuristics to filter these link candidates. Next slide. And then after that, we have to disambiguate the link candidates. For this, we use a set of different features associated with the links that we have identified. One is the frequency, how often we have seen this link before. Another is how similar is the title and the page, or even the semantic similarity between the source page and the target page. And for this, we use language models or embeddings. Next slide. Once we have done this, we train a classifier. So we generate positive examples and negative examples of links. Positive examples are actual links that we found in a sentence in a Wikipedia article. And negative mentions can be mentions that where we generate an incorrect link, or mentions that are not linked at all. And then we just train a relatively simple binary classifier to distinguish between positive and negative examples. And we do some evaluation to see, well, how well does it actually work? We do an offline evaluation based on a held out test set of linked sentences, but we also did a manual evaluation with volunteers and ambassadors from different language communities, 6 communities in total. And we have found that around 7, it varies across the different language version, but between 70 and 92% of the cases, these link recommendations were judged useful. We evaluated them. That was, for our purposes, considered enough. This was a process over many iterations, improving the model to reach this state. And we have found a recall of 30 to 66%. That might sound low, but this is not the main concern here. So it is only, the main focus was on the precision to reach a minimum threshold to be sure that at least in this many cases, the recommended links are considered useful. The obtained model that we can train for any language in Wikipedia is all the models and the data sets are published. They are online, publicly available. You can tinker and play around with them. The growth team has built an API that is hosted on Kubernetes that you can also explore and you can inspect the recommendations for an article, but they're then actually used for the actual link newcomer task for link recommendation. And this you can see in the next slide is the actual user interface that the growth team produced, where you see the link recommendations produced by our model. The editor or the newcomer gives feedback on those recommendations, so they can accept the recommendations or reject the recommendations. They can give additional feedback. They receive an edit summary, and most importantly, these edits are then saved as proper edits, just like a normal edit that you would do with freeform editing. The final question then is, when people use this, the newcomers use this interface, did it work in practice? And I'm presenting here summary results from 4 pilot wikis in which this was deployed is that from many thousand edits that newcomers prefer the structured editing over unstructured editing. The revert rate of the structured edits is much lower. So it's 7.9% versus over 25% for unstructured tasks. Careless editing, so just accepting all the suggestions, is very rare. It's below 9%, I think. And qualitatively, the reactions from community has been mostly positive. It is by now currently deployed in 10 Wikipedias, and the growth team is planning to run and train these models for more languages, and this is coming. And with this, I am done and pass it on to Miriam.
Thank you very much, Martin. So I'm here again, and I'm here to tell you about our projects around image recommendations. So the problem here is that Wikipedia is missing many images. We know this as anecdotal evidence when we browse Wikipedia, and this is a problem because images are an intrinsic part of free knowledge, and they can really help complement and enhance the article's content. And so actually there are many community initiatives, editathons and campaigns like Wikipedia Pages Wanting Photos that encourage editors to add images to Wikipedia articles. The problem is that Wikipedia is missing many images. So around 50% in average of Wikipedia articles is not illustrated. And if we think about raw numbers, English Wikipedia only is 6 million articles. This means that 3 million articles do not have an image. And some articles might not need an image, but most do. So the scale of the problem is huge. And while community initiatives are doing an amazing job in trying to bridge these visual knowledge gaps, structured tasks, like the task Martin has just described, similar to add a link, could help close this gap even further. And so the growth team, as part of this annual plan, has as a goal to deploy the add an image structure task. This is a new task that basically will help newcomers adding images and their caption to Wikipedia articles. Basically, a newcomer will be presented with an unillustrated article and a possible image match for that article. They will have to say whether the match is good or not, the image match is good or not for the article, and then they will invite it to add a proper caption. Now, in order to generate the recommendations of the image to article matches, the research team has developed an article for image recommendation. The logic of the article is relatively simple. Given an article that is not illustrated, it's going to look on Wikimedia Commons for the best possible match for that article. And while the pipeline could seem relatively simple, actually putting this into practice is not a trivial task, because adding images to articles is not a trivial task, not manually nor automatically. Manually finding good images for articles is hard because sometimes the space of possibilities that of the possible images that could be a good match for an article is too huge. And so especially newcomers might find it difficult to also find, for example, good free license images to be added to articles. And sometimes the space is too small because traditional image search engines cannot retrieve free license images for unillustrated articles because sometimes these images do not have enough metadata to be picked up by search engines. And so an algorithm can help reduce the space of search for finding good images for articles, but also developing an algorithm for image to article matching is not a trivial task, a bit because of the absence of good metadata for images, but also because if we want to incorporate this into a structure task, there are a few requirements that are extremely important for the algorithm to be used. First, we need to have explainable image article matches. This means that when we generate recommendation, we also want to provide an explanation for why the image is a good match for an article. And then images are extremely visible in articles, and the power of images is huge. And so having accurate matches is crucial in order to make sure that actually that this important part of the content is of high quality. And also, while we have the skills in the team to develop computer vision technologies that can help these image to text matches, the current technologies are not developed enough to identify the fine-grained semantics needed for image to article matches. On top of that, we need, for the link recommendation task, we need language support for all languages on Wikipedia. And so to solve this task, we went to a relatively simple solution, which is very much inspired by what the community has been done so far in terms of automated tool to recommend images, especially to Wikidata items. What we do is that given an unillustrated article, that we first need to identify what that is, because finding unillustrated articles with the current data is not straightforward, but this is a separate problem. So given an unillustrated article, the algorithm is going to look for possible, across all Wikimedia projects, for possible candidate matches for that article. And then after some filtering, the algorithm is going to prioritize and rank the images so that at the top of the ranking, we have the best possible image matches for the unillustrated articles. More in detail, what this algorithm is doing is heavily based on Wikidata because of the multilingual nature of the algorithm that we want to build. So the first thing that the algorithm does is that it's going to look for the Wikidata item corresponding to an unillustrated article. If there is no Wikidata item, we cannot do much. If there is a Wikidata item, the algorithm now is going to look for possible image candidates. It's going to do so by looking at some property, specific property of the Wikidata items. The P18, which is the actual image of the Wikidata item. The P373, which is the commons categories that is linked to the Wikidata items and that contains images that are highly relevant to that Wikidata item. And is going to look for all articles in other languages that are linked to that Wikidata items. Is going to look for the lead images of the articles, so existing images, and is going to collect this pool of candidates, do some filtering to eliminate bad images that we don't want to see as part of the output of this algorithm. And then if after this step there are still some candidates left, we are going to do some prioritization of the output of this step by looking at the reliability of the source of the candidates. So for example, we know that images that are actually coming from the Wikidata items are more likely to be good matches than if they come from the commons category. So we're going to do prioritization and then output the recommendations. But this is how the algorithm works. And it is right now being deployed by the growth team. And in the add an image structure task. To test the effectiveness of the algorithm back in April, May 2021, together with the Android team and thanks to the platform engineering team, we have deployed a feature on the Android app called Train the Image Algorithm, where editors were asked to annotate the goodness of image to article matches. And this was also to test whether the engagement with this type of structured task would be high or not. And what we found is that the engagement is pretty high, so editors tend to like this task, and that also the precision of the recommendation is pretty high. It's in between 76 to 93% accurate, depending on the source of the recommendation. One drawback of this very relatively simple approach is that the coverage is relatively limited. So we are able to recommend images for article only for 4 to 25% of the unillustrated articles in a Wikimedia project, in a Wikipedia. And so in order to expand this coverage, we need to do more research. And part of the research that we're doing is also to call out the scientific community, our scientific community, to solve this extremely hard problem for from a machine learning perspective. So there is this Kaggle competition that Martin was mentioning, that is essentially asking participants to find the closest piece of text to an image on Wikipedia, where the text is a caption or an article title. Please join in if you're interested, or reach out if you want to hear more information about this. And with this concludes our part on image recommendation, and I'm going to turn it over to Isaac, who is going to tell us about equity in recommendations.
Thank you, Miriam. I'm Isaac Johnson, research scientist with the team, and I'll be talking about equity and recommendations. Next slide. So yeah, as you've heard, there's a lot of exciting recommender system work currently going on in research. And these recommender systems that this research is supporting are facilitating a growing number of edits. So suggested edits, which is a tool that's part of the Android app, has led to 300,000 edits on Commons. These are things like captions being added or translated, and 825,000 edits on Wikidata. These are Wikidata descriptions. The newcomer tasks recommender system, which the Inc. is a part of, that whole system has led to about 190,000 edits across 70 different language editions of Wikipedia. And the content translation system, which Diego's section alignment work will feed into, that system is already responsible for about 1 million articles created across all Wikipedias. And the scale of these edits raises the question of how do these recommender systems align with our knowledge equity goals? And this is a question I've been working on. I think there's two particularly salient aspects to it from a research perspective. The first is just about basic coverage, and you heard this in a lot of presentations. When we build a new ML model or recommender system, what languages or projects is it available in? Now, we've already had success in building certain models that are language agnostic. That is, we start by building a model that covers all languages on Wikipedia and then consider more language-specific tweaks. The second aspect is how do we measure what types of content on wikis are improved by these recommender systems? And how might we empower editors and organizers to use these tools to close the content gaps that are important to a lot of us? Next slide. So here, this is one example of how we can approach some of these questions about the relationship between recommender systems and equity. This Sankey flow diagram here shows an analysis that I did on how the newcomer tasks module mediates the distribution of edits on Russian Wikipedia to articles relevant to various countries. As you see at different stages in the recommender system, the geographic bias most notably shifts between articles about Russia and articles about the United States, according to some of the decisions made in the algorithms at play here, as well as selection bias by the editors. And I can talk about this for a long time. I'm happy to take questions about it later, but instead I'm going to ask our other presenters about how these concepts fit into their work. Next slide. So I'm going to start with Diego and your section alignment work. Now, Diego, you mentioned that you're currently working to scale your initial model to many more languages. And then, as mentioned, the language coverage is a huge component of equity. Can you talk about some of the challenges that you face in doing this scaling and what sorts of features you can use that are less language specific? Muted, Diego.
We can't hear you. Diego, we can't hear you. Sorry.
No, perhaps we come back to Diego then. All right, so let's move on to the next person then.
Now you can hear me?
Oh, yes, perfect.
Let me go back. Yeah, sorry, double muting. Yes, I was saying that this is a very good question, Isaac. Thank you very much. Let me tell you. I think that the main problem here is what you have when you work with natural language processing and you want to map languages is this problem of the rich gets richer. No, so basically languages that has a lot of resources, that has a lot of content. Usually it's easier to work with them, but when you have under-resourced languages that we don't have that many articles, and that in general in the NLP community has been not being considered a lot, are usually more difficult to work with. So basically, it's the quality of the alignments that you get, for example, in the section alignment, would be always very related with the amount of parallel data that you have in these pairs of languages. So if you have two languages that are not very well resourced, or we don't have that many articles, the quality will be worse than if you have a lot. And this has a second implication that is what we will call cultural colonialism. So given that you have much more information and better quality of information, of embeddings and of resources for NLP in few languages, especially in English, it's more likely that the content that is produced for the English-speaking community ends up in smaller communities with under-resourced languages. And this is, and we know that this is not good, not only for like ethical reasons, but also implies a lot of risks. If you have more diversity, always will imply that it's more difficult, for example, to introduce bad content, hoaxes, or these kind of things in the content. And about your question regarding non-language specific features, the main thing that we have, and you know this very well because you have been working a lot on this, and we have worked together on this, is how we can use Wikidata as a spine, as the core of all our non-language specific work. So basically transforming every word every link in a Wikidata item is something that really helps to go to a language agnostic approach and improve systems across languages, without needing to have a lot of resources on the language. So I encourage all of you to keep editing Wikidata and adding more and more information there, because I think this is the best tool that we have nowadays to deal with this problem of inequity on language resources. Thank you.
Thanks, Diego. Yeah, that speaks to the importance of doing this work early, because as you said, if you don't build it into the algorithm, the approaches you design rely on large amounts of data and just end up generating data for places where there's already lots of content available. All right, we're going to now move on to Martin. So Martin, the link recommendation work that you presented had at its goal support for newcomers. However, we can also consider this from a content equity angle, where adding more links can make content more visible and help to close various knowledge gaps. So could you speak to some potential approaches to how you might consider prioritizing different links to recommend with this in mind?
Yes, thank you, Isaac. This is an excellent point. At the moment, in the current link recommendation, as a structured task or add a link structured task, there's no prioritization, no explicit prioritization of links. The main motivation here is that this was on the focus on making it easier for newcomers to have positive and productive edits and a positive editing experience. However, we know that we might reproduce with this essentially naive approach, we might reproduce existing biases. So the knowledge gaps that we have explored in the taxonomy of knowledge gaps, we know that they are also represented in the link structure as well, of how articles are interlinked. So this might be less well known. We know, many people know, it's very well known that the number of articles on women, for example, is much, much lower than the number of articles on men. But we also know that women are much less visible in the network if we look at different centrality measures, for example, of page rank or so on. We also know that campaigns, that while they are very effective at generating or improving specific content, they are struggling to improve or increase the visibility of articles in the same way. And this is well documented for the gender gap. Most likely other gaps are very similarly affected. So therefore, we have been starting to develop general approaches that could help us in this regard. Specifically, we try to identify which links should we prioritize to increase the visibility of articles that are not as visible as they should be. And we have started ongoing research to do that, do prioritization in this link that can hopefully solve this issue more generally, but also then once we have identified, and this is ongoing research, a more general approach to that can also be applied to a specific gap, to specific gaps like the gender gap, to increase, for example, the visibility of articles on women.
Thanks, Martin. Yeah, I really like the link recommendation work. I think it underlies a lot of the other work we do, and really excited to kind of see these additions being made to it. And finally, we're going to return to Miriam. So the logo on this slide is for Visible Wiki Women, which is a campaign that focuses on images, adding images specifically to articles about women. This and other efforts have focused specifically on image representation on Wikipedia as a highly salient aspect of equity, literally the question of whether certain communities of people are visible or not on Wikipedia. So on one hand, your work offers some promise to support this and related campaigns. On the other hand, we've also seen many high-profile incidents at other tech platforms when it comes to using AI to tag imagery. So as you build these image recommendation systems, what considerations are you making to prevent potentially damaging or offensive recommendations?
Yeah, thank you, Isaac, for this question. And let me just say that Whose Knowledge and Visible Wiki Women is an amazing campaign. And what we were saying before about images being an essential, powerful tool to communicate and share knowledge, actually also applies when we talk about fairness. So having more articles about women is extremely important. Having more articles with image about women is equally important, because people can self-identify with the content, and especially when it comes to visual content. So I think these campaigns are extremely important for the type of work that we do, and for even the newer generations to get inspired by visible women, let's say. In terms of recommendation and AI models in the space of Wikipedia images, obviously we've seen a lot of things going wrong when it comes to AI models trying to classify or organize images of people. So we are aware of all this problem of how AI models can be discriminative, and the reason also why we are only slowly introducing machine learning into this problem is that we know that when it comes to machine learning and images, then these can create some biases that can propagate across different projects, right? And especially even if we are not going to use these recommendations to replace or to automatically add content, but we're using just these recommendations as part of broader tools for newcomers and for the community to add images. Even the impact of wrong recommendations, especially about people, or wrong classification of people, can harm the community and can harm especially newcomers, and decrease the how these recommender system can be inclusive, right? And beyond the images of people, we've seen in the past years a lot of research looking at how different cultures and different language communities perceive and visual content differently in terms of aesthetics, emotion, and even just the semantics, and because they relate to different cultures in different way. So we need to be extra careful, especially when we recommend images from one languages to other languages, that these type of language transfer is not somehow hurting or offensive for other language communities. In the interest of time, I'm going to stop here. I can talk about this topic forever because, you know, it's very close to everyone's heart. But I think in the interest of time, I will probably just conclude. Isaac, I don't know if you have any last words beyond what I'm going to say in this slide.
Go for it. Thank you.
Okay, thank you. So I'm just going to wrap up. This has been a long presentation and journey towards our efforts towards bridging knowledge gaps. As you can see from the this diagram of the knowledge gaps taxonomy, we are just scratching the surface of addressing knowledge gaps. There are many, many areas on Wikimedia projects where we are missing content, we're missing readers, and we're missing contributors. And our plan for the next few years is to build the tools and research that can help bridging some of these gaps. If any of you in the audience is interested in looking at this type of research, please reach out to any of us. We will be extremely happy to hear from you. And with this, I think, Martin, should I pass it back to you?
Yes, please.
Yes.
I happily take it from here. Thank you so much for now. I acknowledge we are a little bit over time. I apologize for that. I hope we can still spend some time on discussion and Q&A. Before we dive into it, I want to again mention, if you have more questions, please put them in the chat or in IRC. We'll put them, relay them here in the room and go after them. If we will post the slides on the showcase page. If you are interested to follow up on any of the individual projects, there's a ton of links. And with this, I think there's some questions from the audience, and I'll ask Emily if you can maybe, yeah, go for it. If there are questions.
All right, thanks, Martin. Thanks to those of you who have joined us on YouTube. We do have a few questions. The first one is, which recommendation systems for new articles currently prioritize based on equity?
I think that one is for me. So currently we're not incorporating any of these metrics into the recommender systems. We're still at the kind of analysis stage. I can say at least how I envision how it might be incorporated. And it's not necessarily as like an explicit editorial control piece, but thinking about how we can connect things like campaigns, so some of the work or wiki projects, some of the work already going on in these communities to some of the recommender systems that are being built for newcomers or other groups, and trying to bring these two pieces together. And I think that is probably the most straightforward way on this, but at the moment we're still at kind of the evaluate and understand what the current systems are doing and thinking about alternatives. So if you have ideas, certainly interested in hearing them.
Great, thanks, Isaac. Our next question, could the link suggestion tools be integrated with clickstream data to figure out if the links suggested are ones that readers find useful in similar articles?
Yes, I will take that from about the link recommendation. That is an excellent question. The clickstream data, who is not familiar, is a public data set capturing how readers navigate. So it's some aggregated and filtered data set, how readers on Wikipedia navigate from page to page. And there is previous research from a few years ago that showed that this type of data, like looking at data from readers, contains a very strong and useful signal about predicting which links will be added in the future. So the thought is so in that sense, yes, we would expect that this data could help us to prioritize which links would be judged useful by editors and also by readers in Wikipedia. We have thought about and explored this option for this specific use case here, and in the end have not included it for two reasons. The first one is that the clickstream data, the public clickstream data, only exists for 10 or 11 languages, I think. So it is, we don't have this for all language, or for most of the Wikipedia language versions. We don't have this data publicly and readily available. Therefore, relying on this data would limit us a lot in terms of which language versions we could support this tool with. The second reason is that instead of using the clickstream data, we could use actual data taken from the server logs of Wikipedia. The problem there is that, or the challenge is that this data is not public. So it is actually considered very sensitive. It's actually, we keep this data, but it's purged after 90 days. So this would constitute extreme challenges to making the resulting data and the resulting models that we generate to make that publicly available. And we then decided to have a simpler model, but which can be shared without publicly with the community and can be expected and can be improved in terms of the transparency of these recommendations. Yeah, I stop here.
All right, thanks, Martin. We do have two more questions. The next one starts with a comment that AI can easily amplify existing bias. So if something is truly missing, then it can be hard to notice it. Are there also some more manual approaches?
I can at least give a short answer, but I would love to hear from other folks too. So about the amplifying existing biases, I think that's a huge point. I'll note a lot of the work that was being described here often started out essentially using more manual approaches, and it's only as we really understand how those work and how they interact, how community can use them, that we start moving towards kind of these more scaled up probabilistic AI type approaches. So it's something we try to bake into our design and research process. There are some external tools that try to kind of find missing content. It's not something that we've explicitly worked on recently. Usually when we think about missing content, we think about, for instance, translating across languages, or which was like a piece that, for instance, Miriam with the add image piece is a thing that can be looked at. But yeah, do other folks on the team have additional thoughts? Also, sorry, add one more thing, which is I'll call out the work of our ML platform team right now, which is working on building kind of model cards and ways to evaluate these models and their impact along various lines. So this is something that really working to bring more transparency to, so that, because it's not always clear what, what biases we might pay attention to or what's going to be problematic. And so helping to get data about these is kind of a first step, so that folks can then have informed empirical discussions about it.
All right, thanks, Isaac, for taking that question. And we have one more. Our last question is, are unsuccessful searches used as a source of suggested content?
I can, from the link recommendation side, we are not using, I can say we're not using data from search. More generally, I'm not aware that at least from the research team, we're actively analyzing this data about unsuccessful searches. maybe Leila can comment more generally from previous years, what research has been done. But from my understanding, this data, we don't have a good understanding about what this data contains. Also, few people, I think, from the general reader population use the internal Wikipedia search, so it would also not be very representative in terms of the overall population and what we would capture. So, and this, I think, there's a general lack of understanding of what it captures and what it contains poses strong barriers in just taking that at face value. That is my understanding, though I must acknowledge I have not worked with this data hands-on. So I leave it for others to chime in if they can comment.
Oh, please
go.
I just wanted to add one piece that the search team at the Wikimedia Foundation, I think they can comment better. But in terms of measuring success of image searches or image search results, this is a non-trivial task. It's people have used different metrics, and understanding how users are satisfied and whether the search results are satisfying enough in terms of visual content. It's not a trivial task, because understanding the complexity of a free text, natural language query, and how this reflects into the visual content is a non-trivial task, I think, for human annotators and worse for automatic methods to estimate the success of searches. So it is unfortunate. While I think this will be extremely interesting, I think there is some relatively recent research around this aspect from labs in University of Amsterdam about how to automatically measure the success of search compared to automatically, and that in a way that it reflects like actually subjective perception of search. This is a super interesting topic, and yeah, I don't know much about it. So Leila, please go ahead.
I'll just share a bit that the search platform team, as Miriam said, has access to the data and also is very knowledgeable about the data. Our team has not focused on using the data, as Martin mentioned in the past. I'll say partly because the search platform team has analyzed the data and they have not identified a lot of signal within the data. So that is something that they have multiple times communicated publicly. So that has been also a source for us to say, okay, there's not a lot there. We know from the data we are analyzing that not a lot of people are using search. This is just to add that to what the rest of the team has shared so far.
Thanks so much for these answers. From what I'm seeing, there are no further questions in the queue. If anyone wants to speak, mention any final comments, I'll give 3 seconds. And if that's not the case, I think we're also at time, and it's a good time to cut here. I want to thank the speakers for the presentations. Thanks, Emily, for relaying these questions here. I also want to thank Emerald and Jana for their support to make this happen. And I want to thank the audience, everyone who joined and participated in this showcase. Thanks for your questions. And that's it for today.
Can I say thanks, Martin, for putting this together, because actually Martin put this presentation together and actually suggested us to do this and was very patient with all of us for putting all pieces together. So a lot of thanks goes to Martin.
Thanks a lot, Miriam. I enjoyed this very much. I actually learned quite a bit how our research fits together. I really enjoyed it. I wish everyone a good rest of the day and hopefully see you for the next research showcase in November. And with this, bye.
Thank you. Bye.